There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Luis Quintanilla. Luis is a program manager at Microsoft. He's based in New York and has a deep focus on machine learning and software development. He currently works on ML.NET, helping .NET developers train, test, and use machine learning models in their applications. Outside of work, he enjoys experimenting with different technologies and sharing his insights with the broader tech community. In our conversation, we dive into Luis's work with ML.NET, an open source machine learning framework within the .NET ecosystem. He explains how it can help users build pipelines for data transformations, consume pre-trained models, and train custom machine learning models. It's a great conversation, and I'm excited to share it with you. Well, hello, Luis. Welcome to the podcast.
Yeah, thank you for having me.
It's definitely my pleasure. I'm excited to talk to you today about ML.NET, something that I know you know a lot about. To get us started, maybe for those who haven't heard about it before, could you give the elevator pitch for what is ML.NET?
Yeah, absolutely. So ML.NET, it's an open source, sort of cross-platform machine learning framework within the .NET ecosystem that allows you to do, a variety of things, related to machine learning, right? And I think maybe we'll talk a little bit about terminology a little bit later, but you can just think of machine learning as this sort of subset of the broader AI umbrella, right? And so you can do a variety of things like, building pipelines for data transformations that eventually need to be fed into some sort of algorithm to train custom models, right? You also have the ability of consuming pre-trained models, right? So taking models that are open source, off the shelf, using a variety of different frameworks like, Onyx, there's TensorFlow, right, and a few others. And so that's sort of at the base layer, this common core set of APIs. And then there's additional layers on top of that where we try to make some of the process of training a custom machine learning model a little bit easier. And so those include automated machine learning, which is exactly what it sounds like. It will go try to figure out what's the best, the system will try to go figure out what's the best sort of combination of parameters for your particular data set when you're training a custom model. And then we also have tooling that's built on top of that through the CLI, as well as through tooling inside of Visual Studio that gives you this more of kind of like a WYSIWYG sort of wizard-like experiences that enables you to train these models.
Yeah, that's a really helpful overview of a lot of different things that are available as part of this umbrella that we call ML.NET.
Yep.
I imagine this is a question that you get a lot, but a lot of machine learning stuff, people who are maybe starting to learn about it, they're going to see a lot of Python code. Mm-hmm. And, this is not for Python, it's for C# and F# right now, at least, right?
Yep, you're correct, yes.
Yeah, so how does ML.NET compare to those Python tools? If somebody's like, oh, I don't know, maybe I'm a .NET developer, but I'm nervous about getting into something new. If everyone else is using Python, maybe I should be doing that. How does the tooling and functionality compare to what else is out there?
Yeah, that's a really good question. So what I would say is, first of all, there's no denying that in terms of the content, the community that's sort of built around Python, right? It's just it's amazing, right? It's an amazing community that's built up over the years. But from the perspective of .NET, right, at least ML.NET, it includes, if you were to draw some parallels from a classical ML perspective, right, it tends to be very similar to Scikit, right, in terms of the types of tasks that you can train models for, in terms of the algorithms that are available, the APIs. Obviously, it's going to have more of a .NET flavor. So from that perspective, if you're a .NET developer, if you generally speaking can understand what the concepts are, you can then translate those into a language and the tools and the libraries, right, that you are already comfortable with within the .NET ecosystem, right? And so from that perspective, there's a lot of similarities. I mentioned, for example, also, that it's not an sort of either or, but rather it's this, enabling you to sort of bring those assets that are in the Python ecosystem when you're ready to put these models into production and make that process easier. And so really good examples of that are, for example, with Onyx, right? Onyx is short for the Open Neural Network Exchange. And so typically what these workflows entail is, you're right, from the model development, perhaps you'll have a data science team or somebody who is an expert in this area of training models using the respective tools, potentially in the Python ecosystem, and they'll go and develop a model, right? But from a production perspective, right, chances are that the applications are generally not built with Python, right? Your systems may be in Java, .NET, choose your language for enterprise software development, right?
Mm-hmm.
And so you need to be able to bridge that gap of, I have a model, I need to use it in my production application. And so ML.NET using the Onyx format, typically you'll take the model, convert it into this Onyx representation. And then now you can sort of use the Onyx runtime, which knows how to read that model and run data through it in order to actually make predictions, right? And so ML.NET and Onyx runtime make it super easy for you to sort of bring in those components that may not have been built within the .NET ecosystem, and make them immediately useful to you inside of your .NET applications.
Okay. So thanks to this, are we calling Onyx a protocol or a platform, or is it more of a file format? What would we call that?
Yeah, so that's a really good question, because there is a distinction, right? There's sort of the
Uh-huh.
umbrella, but Onyx itself, it is a format, right, for representing operations or nodes in sort of a computational graph, right? Which that's
Mm-hmm.
effectively what these models tend to be, right? They are these computational graphs that you run data through it, and then in goes some data, out comes the other data that's been processed by the model. And Onyx is a way for defining what that computational graph looks like of operations like adding, multiplying, so on and
Mm.
so forth.
So
And so that's, yeah, go ahead.
if you're on a larger team that maybe the data scientists are building models using uh, some Python tooling or something like that, this
Mhm.
Onyx standard is something that would allow Java teams and .NET teams to make use of that in their applications. Is that true?
Correct, yes. And the thing that makes that possible is the Onyx runtime, right? And so the
Mm.
Onyx runtime, as you can imagine, is you have an Onyx file and it knows how to interpret that computational graph. And then the Onyx runtime is the thing that executes the operations that are defined by that graph, right?
Okay. Oh, that's
Some of the
very.
other things that gives you also is, as you may have noticed, is it wasn't as true with some of the classical ML type of models, right? But having access to specialized hardware for hardware acceleration is also an
Mm.
important part, both with training as well as with inferencing workloads. And so that's the other nice thing that the Onyx runtime sort of gives you. It provides a set of sort of extensions or bindings that enable
Mm.
you to tap directly into the hardware that your model is going to be running on top of, right?
Okay.
Without actually having to know the APIs to program against that hardware specifically, right? So you're not
Mm.
writing, drivers and all these things that you might need to tap into that hardware. Onyx runtime sort of abstracts those things, a
Nice.
level above.
Okay. Well, that is a perfect transition to my next question, which is, it seems to me that one of the benefits of ML.NET is that if you are a .NET developer and you're looking to do some machine learning in your application, that you don't necessarily have to be a data scientist to be able to get started with it. Can you talk a little bit about what ML.NET does to help a non-data scientist uh, engineer get started with machine learning?
Yeah, absolutely. So I think the best place for folks, or the entry point where I would recommend folks come in through, is through our tooling, right?
Mm.
And the way that we tend to, sort of lay out our tooling, specifically in Visual Studio, though the same as possible with our CLI, is we define it in the concept of scenarios, right? Like, what are you trying to do here,
Mm.
right? And I think that generally speaking, with any project or anything that you're trying to do, right, you have to have that problem definition, right? What am I actually trying to solve here? And typically, regardless of whether you're starting with APIs directly, that's the question that you have to ask yourself. And so what the tooling does is it puts that more front and center, right? Where it's like, okay, am I trying to predict the numerical value of something like, I don't know, sales for, for a particular region? Or am I trying to categorize, data as, for example, a set of customer reviews as positive or negative, right? And so, from that perspective, once you're like, okay, here's the thing that I need to do, right? Then through our tooling, we sort of guide you through this process. Like, okay, well, now that you've defined your problem, what is it you're trying to do? I'm going to need data to train a model, right? And so we provide with this wizard that allows you to sort of, tell us, here's the database or the file that I'm going to be using for my data. Here's the thing that I'm trying to, predict or that I'm trying to build a model against. Here's the data inputs that are going to go into that data model, right? And then you go on to the next step. Once you've defined a problem, got your data sources, now it's a step of, okay, I actually now need to train the model, right? And so when you get to that step, generally speaking, through our tooling, the process that you would go through is you would have to pick, okay, well, I know that X, Y, Z algorithms work better on this during this scenario, and I have to tweak the parameters of those to fit my data set. And there's all these decisions that you have to make as to which algorithm you're going to choose to train your model with, because for any given task, there's multiple approaches or multiple algorithms that help you solve that problem. And we try to take that burden off of you a little bit through automated machine learning, which I mentioned, right? And so what AutoML, the way that you can think of what that does is, given the problem that you told that you wanted to solve, right? And given the data set, it will go and iterate, like intelligently iterate over the space of potential models that algorithms that you can use for that specific task. And in addition to that, it will also look for the parameters that fit your data the best, right? And so now you as a developer, you don't no longer have to think like, is it a cart tree, it's a tree-based model? Am I doing sort of vector, support vector machines? You don't really care. Like all you care is, here's my problem, here's my data, go figure out what the best model for it is. Right? And so once that's done, then you get an artifact, which is, what we tend to, even taking a step back, when we talk about these models, all a model is, it's a serialized representation of the patterns that were learned given the data set that you gave it, right? Mm-hmm. That's essentially what it is. And then from a usability perspective, you take this artifact, you feed it new data, and then you get the process data as processed by the model. That tends to be that initial thing that you were trying to predict in the first place. And so with AutoML and our tooling, we try to take some of that burden off, so you can only focus on, what's my problem? What data do I need to sort of give me the answers that I need? And then AutoML, the tooling, goes and figures out the rest.
Yeah, that seems really useful. You don't have to be a data scientist or a statistician or mathematician to actually know. And I assume that that's using some sort of like a statistical best fit type of analysis to figure out which one works best for your data.
Correct. Yes. There is an evaluation phase as part of that, right? Where there are some metrics that you are trying to optimize for, right? And so depending on the problem, those metrics may vary. But the thing is, you're either trying to, maximize the number of correct answers that the model predicts, or you're trying to minimize the number of errors that the model makes. And in these cases, it's either like, you're either optimizing or reducing for something. Mm-hmm. And so that's how you determine what's the best model, because even the term best is also relative, right? So for example, if I was just, categorizing, user comments are important. I'm not saying that they're not, but generally speaking, they're not sort of, life altering or life and death situations. And so from that perspective, right, whatever metric it is that you're optimizing for, you may be okay with like, 80%, 75%, whatever that metric is that you're optimizing for, right? And that's fine. In a medical setting, right, where you're hopefully there is a human in the loop and you're not just letting, the models sort of predict and make decisions. But from that perspective, right, the bar is a little bit higher. And so, again, that concept of best tends to be relative depending on where the model is going to be used.
Okay. That's very helpful. Now, you've referenced a couple of times the tooling that's available for ML.NET, which I think is a game changer for um, you know self discovery. Let's say uh,
Yeah.
learning this stuff on your own. You mentioned the Visual Studio tooling, and you also mentioned the CLI. Are those the two main ways that people can interact with ML.NET besides
Yep.
code, obviously?
Yep, that's right. Yeah. So the tooling is Model Builder specifically. That's the name of the extension inside of Visual Studio, and the CLI is just the ML.NET CLI.
Yeah.
Yeah.
So if someone is doing development in VS Code, for example, they're going to be using the CLI for this. If they're a
Yeah.
Visual Studio person, Model
Correct.
Builder.
And actually, we welcome. Actually, a few years back, we had a community member who built their own model built the GUI, if you will, right, for the CLI in VS Code. I don't think that project is maintained anymore, but again, because it's just a CLI, and from a GUI perspective, you're just passing commands into it. Folks are welcome to sort of build these types of experiences and extensions on top of the tooling that exists today.
Okay. Yeah. So if someone's looking to maybe get involved in an open source project, maybe they could help maintain that.
Yeah, absolutely.
Um, so you've also mentioned how ML.NET does different parts of the life cycle.
Mhm.
It's not just running a model that already exists, but it's all the parts that come before that. Can you talk a little bit about what that looks like for that earlier parts of the life cycle if you're doing that?
Yeah, and just to make sure, like, is it more from the like the problem definition space, or
Yeah, I'm thinking like creating and training and evaluating models, basically.
yeah? So ML.NET has first of all, there's the algorithms, right, which are sort of built in, right? There's a bunch of algorithms that are just built into ML.NET, depending on the task and the scenario. And we also have with those sort of algorithms, we also have the metrics that are available to you, right? And from that perspective, again, the sort of the AutoML set of APIs just make it super easy for you to go and really just focus on your problem set. And one of the things that we also try to do is training a good model is, well, there are many factors to it, right? But typically, you need good data, right? And so from that perspective, the tooling, one of the assumptions that we make with the tooling is that you have figured out how to sort of, prepare your data in a way that will give you the maximum sort of, predictability as far as whatever it is that you're trying to predict, right? So from that perspective, we don't necessarily have an opinion in the tool in our tooling and in our framework. We kind of assume that you've gone and sort of prepared your data how it needs to be. Uh, and so one of the things that we then try to do is with AutoML is we try to take this data and apply what we think is best, and from the perspective of the factors that you need to build a good model. There's the data, so garbage in, garbage out, and also
Hmm.
time, right? Because through this exploration phase, you need to be able to have enough time to go figure out what might be the best solution. And so that can be, and so from a ML.NET, AutoML, and tooling perspective, right? One of the things that we sort of offer you as sort of the threshold, or a thing that you can set throughout the training process, even though you're not actually selecting the models individually, at least not to start, or the algorithm specifically to start off. We give you this sort of time to train parameter that you can set, right? And so during this time to train, it's sort of like if you want to go and prototype something, you can quickly go do that, right? So you don't need to spend, I'm sure folks may have seen from, the various Gen AI models that are out there today, that it took a few weeks and several hundred hour, many hours and X amount of money to go and train these systems, right?
Hmm.
And from the tooling and sort of the systems that ML.NET provides you, you're able to do that on your laptop, right? So you're able to go and validate, hey, am I actually doing, am I going down the right path, right? And so instead of it being many hours, you spending many hours only to find out I'm totally going in the wrong direction, right?
Hmm.
By setting it to like maybe an hour, maybe a short amount of time, you can go and validate, and sometimes get a good enough model to validate and prototype. Like, hey, yeah, this thing works. Now let's go and do the real job of going and training a real model here. Which again, it may not necessarily be hundreds, thousands of hours, right? But at least you get to prove early on whether this is going to work or not. And then from so that's the early on process. We also help you out with the deployment plot process as well, because once you train a model, for example, with Model Builder, and even with the CLI, we go ahead and scaffold a project for you to host your model, right? So once you're done, you're happy with your model, you've evaluated it. We provide you with this sort of GUI, at least in the in Model Builder and Visual Studio. We provide you with this GUI where you're able to like actually try out the model, right?
Mm.
To sort of spot check. So you're not only relying on the metrics, you also have this sort of way to test your inputs, right? Like given this input that I'm providing to this model, is it actually responding with stuff that makes sense here, right? And then that last mile of the deployment piece, from that perspective, we scaffold the project. You can have an API, ASP.NET API, web API, right? And we just wrap the model, give you all the code that you need to then just go and take this to production. At that point, it's just an ASP.NET application, right? So as a .NET developer, it should feel familiar and easy for you to now go and take this to production.
Okay. Interesting. Uh, that actually brings up a question I have, which is, in all the live demos that you see of ML.NET, people are running the training for maybe 10 or 20 seconds or something like that because it's a live demo and you don't
Yeah.
want that going for hours.
Mm-hmm.
Is there like a recommended based on size of data, or is there an amount of time that you find that's kind of the point of diminishing returns? Or what are the
Yeah,
scale of
that's
those numbers for real life production
Yeah, that's a good
models?
question, and it's going to depend, right? Because as you might imagine, even though you're not, at least with classical ML models, what is something that I'll mention is you have the classical ML and ML.NET. You also actually have deep learning models, which we introduced in a couple of the latest versions in ML.NET. So you can do a lot of the natural language type of tasks, like entity recognition, classification, but you're no longer using the classical ML type of algorithms, right? You're using more of the deep learning type of algorithms. And so many of them are actually using the transformers architecture, right, which folks may be familiar from, from sort of the Gen AI, set of models, which follow very similar. So we're not saying you can go and train a GPT quality type of model, right? But you can certainly train, smaller, more task specific models with ML.NET. And so we have both classical and deep learning. And depending on which one of those you choose, it may take, you know, less time or more time for you to train. And as you might imagine, the deep learning ones tend to sort of benefit from the hardware acceleration that a GPU might provide.
Yeah.
And at the same time, they also, need more compute resources, generally speaking, right?
Sure.
And
So
so,
if you're processing images, say, or video or something, that's going to be
yeah,
a heavier
exactly.
lift. Yeah.
Exactly. And so from that perspective, right, you may not want to lock up your, laptop or desktop to only have it do that for, 6 hours or whatever it may be. And so from that perspective, right, you might choose to use the CLI for these longer training jobs, right, versus using the Visual Studio extension that we have, which is going to, it works best if it's running on your PC. Right? In terms of heuristics, certainly one of the things that we try to make recommendations on is like, I think it's something like, kind of like a more of an exponential type of thing, depending on how many megabytes of data you have, it's sort of, give or take, it's, what do you call it? Like depending on the size of your data, right? It's exponentially the number amount of, minutes or hours that you may want to train. It's a heuristic, but honestly, it's not a perfect one because, to your point, you may get to a point through the training process where the metrics are no longer moving, and so like maybe within the first hour, you sort of hit that peak, right, of whatever metric it is that you're choosing to optimize for, and then from there it's just flat, right? And so there are some mechanisms in place that we have, for example, with AutoML to do some sort of early termination, right? Where you're like, hey, if you've seen that after X number of runs or trials trying to find the right algorithm, you're no longer improving, just shut it down, right? And so there are some of those mechanisms that are sort of available to you, so as to even if you were to set it for, let's say, 6 hours and you're okay with that, in the event that it's not no longer being the metric is no longer being optimized, the system itself will shut itself down.
Okay. Oh, that's cool. There's a competitive uh, product that's available, or service that's available through Azure that I'm sure you're familiar with, an
Mm-hmm.
Azure ML offering. And, one of the things that I run into as a consultant a lot is people kind of confusing those two or not being sure what the difference is, or maybe even like the different scenarios that each of those offerings would be more useful for. Could you talk a little bit about how you see that breaking down?
Yeah, absolutely. So, I personally, it's a great question, and there's many angles to it. So, for one, I see, Azure ML is a platform that gives you beyond just the ability to train models, right? It's the compute, it's the model monitoring, the operationalization aspect of things. It's your data set tracking, and so it's a much more holistic end to end sort of platform for building AI, machine learning applications. And ML.NET and Azure ML, in many regards, sort of complement each other from the perspective of, for example, while we enable you to train models locally using ML.NET, we also have the option for you to go and train on, especially the deep learning type of models, for you to go ahead and train on Azure. And the thing that's actually backing a lot of that training process, the compute, and things like that, it's actually Azure ML that's doing that for you, right? And so we provision the compute for you. You go ahead and you train the model, and then what you get back is the artifact, which is the model that was trained on Azure ML, right? And so for some of our scenarios, they actually tend to sort of complement each other, right? And then there's the other one as well, which is more for off the shelf, which is the now called AI services, and you have the cognitive service, which are more like pre-trained models that you can use for the bots. And then from that perspective, right, chances are that in many cases, those models, like for example, I think the most recent one that was either announced or talked about was Florence or Florence 2. That's sort of a computer vision model, right? That's typically one of those models that was trained, large GPUs, tons of data, more wide ranging sort of scenarios, right? And so in many cases, the AI services that are out there that you can sort of use off the shelf tend to be, sort of bigger models, right? So very similar to what you're seeing with the Gen AI wave today, which is like, hey, your beefier models are your Claudes, your GPTs, like the
Mm-hmm.
ones from Google, right? Like those large language models are just super capable and have a ton of features and capabilities, and sort of do a really great job at whatever the task is that you present them with. And then you also have these smaller language models, right, where they're good at certain things, but they don't have the level of capabilities that say one of those larger models has. And so if you were to sort of look at it in contrast, with ML.NET, you can build some of these more smaller models. If you have the data and the compute, you can certainly get close to those sort of bigger models, right? But generally speaking, the focus is to enable you as a .NET developer to train your own models, and depending on the complexity of that, chances are they're going to be sort of on the on the smaller side. That said, right, like there's nothing preventing you from going and developing your own sort of model that rivals in many regards, if for a given task, some of those larger models. It's just, again, it comes back down to how much compute do you have, and how much data do you have. And in the case of Azure ML, it's sort of that enabled platform that, hey, I may not have that on my device here, but I know
Mm-hmm.
I can go spin up resources in the cloud to enable me to do that.
Okay. Well, that's nice that those two services work together in those ways. What about like offline, models? If you have a mobile app that you want to be able to do some machine learning recognition of something in an offline scenario, is that a better fit for ML.NET than Azure ML?
Not not necessarily. Well, let me take it to split the question into two. So because Azure ML is not actually providing you the model, it's actually just providing you with the tools, the infrastructure for you to be able to train your own custom models, right?
Mm-hmm.
The model artifact itself may, generally speaking, be end up being the same, right?
Mm.
And so whether you train it with ML.NET locally in your PC, or whether you train it in Azure ML, right, the artifact that gets produced as a result of that is generally going to be the same. And
Okay.
so from the same from the perspective of like assuming that you were training both an ML.NET model locally and training one in Azure ML, you're going to get the same model, right? Um, Now, bringing that down sort of for local inferencing is like once you have the artifact, you can kind of like do whatever you want with it. And so, for example, one of the things that sort of Azure ML provides you is they have these sort of I forget what the actual term for it is, but you can think of them as these like sort of managed deployments, right? Like once you have the artifact, it will actually go and provision compute for you to then host this in Azure, right? Now you have this endpoint that you can hit very similar to the AI services or OpenAI set of services that you have out there. There's an endpoint that I can hit. Right? Obviously, that's not going to work for local scenarios, right? And so, as long as you have the artifact, whether it was trained in Azure ML or whether it was trained in ML.NET, you should be able to use that artifact inside of your Maui or your mobile.NET application without generally speaking, without a problem.
Hmm.
That said, the things that again we can't necessarily remember physics is like if the model is large enough, right? Like you obviously can't fit like a GPT level model because it's just that's all that's going to be on your device. There's no room for pictures or anything, right?
Yeah.
And the second part of that is the compute, right? Like, do I have the necessary compute to be able to like process the amount of data that is needed by the model, right? So those are the only limitations that I would say. Where the smaller models, right, tend to actually do really well on more smaller devices, right? And rightfully so because of compute and storage.
That's the perfect engineer answer. It depends. I like
Yeah,
that.
yeah,
um, so this episode comes out in about September, so just a couple months before .NET Conf, where
yeah.
I imagine there'll be some ML.NET content. Is there any previews you can give us of the kind of stuff that you might be talking about there?
Yeah, so I think folks in general, right? I think the agenda is still under development, but there's a lot of his stuff that we are going to be talking about AI, and so just the broader scope. Like in this case, we've sort of focused on ML.NET, but there is this sort of broader world out there, especially that you've seen with sort of Gen AI. So there's going to be a lot of interesting stuff that we're going to be talking about there regarding Gen AI, regarding patterns, right, in the ecosystem, and at some point, sort of probably for a separate conversation, Gen AI has sort of exploded onto the scene, right? And that's the area of interest now. Um, but again, right, like going back to that it depends answer, under certain scenarios, you may want to choose a different tool that may best fit your technical and your business requirements, right? And in those cases, it may not always be Gen AI. And so that, at some point, not one for predictions, but at some point, right, I think it's going to be evident that you're going to need to use the right tool for the job, right? And sometimes that's going to be Gen AI, sometimes that's going to be the smaller classical models, and it's just going to depend on your scenario. And so, like, either this one or in the future, right? Some of the things that you can look forward to is really understanding how to blend both of those worlds together, right? And how to reconcile those worlds, where it's not either or, but rather a complementary sort of solution.
Okay. Yeah. Interesting tease. Be looking forward to hearing more about that in a couple months.
Yeah,
So
absolutely.
we've been talking about ML.NET and how that can help you make AI more successful in your software projects. But that's the theme of this podcast, Blue Blazes, in general, is how to make software projects more successful. So I'm curious, Luis, if you have another topic in mind that you think we should cover, or maybe someone else that we should be talking to about that topic here on the podcast.
Yeah. So I'll answer that in two ways.
Okay.
One is, I don't know if you had folks talk about data before in your podcast, but if you haven't, I would definitely recommend talking to folks who are experts in this area because, generally speaking, algorithms aside, parameters aside, the underpinning sort of challenge or theme here tends to be data. And as I mentioned, right, like garbage in, garbage out. So you got to make sure
Mm-hmm.
that the quality of your data is really good, right? In order for you to be able to train, high quality models. And so
Mm-hmm.
that's such an important step. And even when you do have a model, right, there is sort of these pipelines that you need to put in place to be able to pass data into the model and sort of do something and do some sort of transformations on the other side once that data comes out, right? And so being able to sort of efficiently and effectively manipulate and work with data is a critical piece to any AI and machine learning workload. And then the other one is, honestly, like none of this is possible without community. I think you had an episode on community before, but there's a lot of really exciting projects that are taking place, in the community. Some of them in the .NET ecosystem, and some of them are not, right? But a lot of what the community is doing in the space is certainly driving innovation, and driving the space forward.
Yeah, that's a good one. And community is one of the best places to be learning about this stuff, right? All the cool tools that I use today are
Yeah.
things that I heard about once first from somebody at an event or something, right?
Yeah, I mean, in many ways, what you're doing here with this podcast, that's kind of what it is, right? It's talking to folks that are building stuff and learning from them. And on the, .NET and AI space, there's a ton of folks that, from projects like FS Lab, where they're building these statistical libraries. You have the sort of SciSharp folks, right, who are focusing on like sort of TensorFlow and some of these other areas in the .NET ecosystem, right? There's a lot of really exciting things happening. Our Torchart project, even though it's under Microsoft, it actually has a lot of community involvement there. Yeah, I mean, I think learning from the community how they're building these systems for AI and working in this new space would be incredibly insightful conversation to have.
Yeah, very good suggestions. And thank you very much, Luis, for your expertise on ML.NET and getting us started thinking about that a little bit. Really appreciate your time today.
Yeah, thank you for having me.
Yeah, it's been a real pleasure. Thanks again.
Thanks.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one, with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.